Okay, so today we're going to talk about a concept called the mole concept. So I want you to take a guess about how many molecules of water you think are in one sip of water. So let's say a sip of water is about 18 milliliters of water. Okay, so about 18 milliliters of water, how many molecules of water do you think there are? Go ahead and write down your answer. Um, there's no way for you to share it with me right now, but I'm pretty sure that your number is not big enough. So why don't you add a couple more zeros to it? Would you like to know the real answer? I'm sure you're wondering how I know the answer, and I'm going to get to that at the end of this talk. But there is an answer. There is an exact number that we can actually figure out. So I'm sure you'd like to know how I know the answer. But here it is. The answer is this. This is how many molecules of water there are in 18 milliliters of water. Now, this is actually a very special number for us. And because we're going to be using it a lot, I'm pretty sure we're not going to want to keep writing this out because it's a lot of zeros. So we usually represent numbers that are really big or really small in scientific notation. Do you remember that? Okay, well, I hope you do. But anyway, this is a very special number in chemistry. It's called Avogadro's number. It's named after the scientist who came up with it. And obviously, we can talk about how he developed it. But first, let me talk about why it's so important. It's actually just a number, just like a dozen or a pair, but it's a really big number. And the reason why we need this number is because we want to keep track of atoms and molecules that are really small. So let me explain why this number is useful. Okay, let's say the copy machine is out of paper. Happens all the time. Now, when we need paper for the copy machine, do you think I'm going to want to count out sheets of paper? No, I don't. It takes a long time. The paper's really thin, but basically what we can do is we can get a ream of paper, which is always exactly 500 sheets, okay? So exactly 500 sheets of paper in a ream. That way I don't have to count out how much paper I have. I know once I have one ream, I have 500 sheets. If I have two reams, then I would have 2 times 500, which is 1,000. If I had 3 reams, anyway, you get the point. It's really easy to keep track of the amount of something because I've packaged it in this quantity. We do the same thing sometimes with quantities like dozen. We buy a dozen eggs, and we know that that's exactly 12 eggs. If I say 2 dozen, then I know I'm talking about 2 times 12, which is 24. Anyway, we'll do the same thing with that number, which we call Avogadro's number. Okay? So that number is known as 1 mole. So 1 mole of anything is 6.02 times 10 to the 23rd of that item. So a mole of atoms, 6.02 times 10 to the 23rd atoms. A mole of shoes, 6.02 times 10 to the 23rd shoes, right? So we can use this number to refer to anything because it's just that. It's just a number. The reason why most people get intimidated is because it's a very big number and sometimes really hard to conceptualize. So we'll talk more about the mole and significance of it and sing songs and all that, and we'll celebrate the mole on Mole Day. But just get used to hearing that word because you're going to hear it a lot, okay? All right, so let's talk about how I actually figured out how many molecules of water you have in 18 milliliters of water. Okay, so let's look at this. We know atoms are in different sizes and masses, right? We've just figured out that a mole of atoms would have, one type of atom would have different mass from a mole of another type. For example, if you ask me how much does a dozen weigh, does that question make any sense? You would want to know a dozen what? So if I asked you how much does a dozen weigh, you would say a dozen what? A dozen eggs, it does in donuts. Yes, you're absolutely right because it depends on what you're talking about. And the same happens with a mole. If you say to someone, how much does a mole weigh? The next question is, a mole of what? So that's where things get interesting because all we have to do to figure out how much a mole of anything weighs is look at the periodic table at the atomic mass. The atomic mass that you see on the periodic table is in a unit called AMU, atomic mass units, but we use that mass in grams because that is the mass of 1 mole of any element. Isn't that cool? So 1 mole of hydrogen is 1 gram. We're just going to round off to the first decimal place. 1 mole of oxygen, 16 grams. 1 mole of lead, 207.2 grams. Okay, well, we don't need lead right now because we're talking about water, but it's basically very straightforward. So let's look at how we can use this for water. So we just said that a mole of any element is 6.02 times 10 to the 23rd atoms, and that mass is going to be the gram atomic mass, the mass that you get from the periodic table, but in grams, okay? So it makes it really easy to keep track of how many particles we have because we can weigh it. We can get the grams, okay? So we have something called the atomic mass, as you know, which is on the periodic table. We're going to use that as the grams per mole of that element. And then if we have a compound, all we have to do is add up those elements, and then we have the mass of 1 mole of that compound. Easy. Okay, so let's do an example. Let's say I'm talking about water. So water has a formula H2O. So that means there's 2 atoms of hydrogen and 1 atom of oxygen in a molecule. So if I want to find the grams of water in 1 mole of water, I'm going to say 2 times 1 plus 16, which gives me 18. That means is 18 grams is 1 mole of water molecules. Well, the density of water is 1, so 1 gram per milliliter. So that means if I have 18 milliliters of water, I have 18 grams of water. If I have 18 grams of water, I have 1 mole of water. Isn't that cool? I think so. So that's how I knew that 18 milliliters of water, which is the same as 18 grams of water, contains 1 mole of water molecules, or 6.02 times 10 to the 23rd.